In the present video, I will be explaining the following problem. A government defines poor pay as below 40% of the average pay. 10% of workers are poorly paid. Assuming the pay is normally distributed, calculate first, the coefficient of variation of pay. Second, the probability that a randomly selected worker is paid more than 30% above average pay. I consider this problem a very interesting exercise of a normally distributed variable. So they tell me that it's normally distributed. And usually a problem of normal distribution, when the question is what is the probability that the random variable take some special values, have two data that always appears in each of these problems. First, they give me the mean, and also they give me the standard deviation. So this problem is very interesting for that, because they don't tell me none of this value. They don't tell me what is the mean. They don't tell me what is the standard deviation. However, they give me some information, and maybe the first question here help me to have an idea of how to solve the problem, because they ask me for the coefficient of variation. If you remember, this coefficient of variation measure the relation between the standard deviation and the mean. Maybe we cannot get the mean, we cannot get the standard deviation, but we can get a relation between the standard deviation and the mean. So let's solve this first problem, and then we think in the second about the probability. So let's solve the first problem. What is the coefficient of variation of pay? So let's see the information that we have. We know that 10% of workers are poorly paid. So there is a probability here, there is a proportion here, 10% of workers are poorly paid. Because this is a normal distribution variable, so what I'm going to do is just make a graph of the normal distribution. This will be the distribution of the pay or of the wages of the workers. So it's normally distribution, and we know that here in the middle we have the average, so or the mean. So let's type here in the middle what is the average. So the average will be here. And they define poorly paid a proportion of workers that are below some special number. And this number that is here will be 40% of the average pay. If the average pay is mu, then the number that divides this 10% and the rest of workers will be 40% of the average pay. So let's type here 0.40 of the average pay. So it will be 0.40 mu. So what this problem is telling me is that this region here below this 40% of the average pay is 10%. With this information, we can get what value of z in the standard normal distribution correspond to this 0.40 mu. So let's check the standard normal distribution. In the standard normal distribution, the mean is 0. So let's type here 0. And we can find this value z that appears here. And then use the z-score formula to find a relation between this z and this value of x. So let's type the formula here. And so this z will be this, the value that we're going to put here. And the value x that you can see here, this value x, is the one that I'm going to type here. And we can use a table or a software to find the z that have 10% below. So this z here that have this 10% below. Let's use, for example, a table. If you use a table, and in the region of the table corresponding to the areas, try to find the value 0.10, 10%. So what value of z corresponds to this 10%? So let's find 0.10. They are in order. Here is 0.08, 0.09, 0.10, 0.3. We don't have 0.10, but we can use the one that is the closer one, this 0.10 here. And this 0.10 here corresponds to a value z of negative 1.2, as a second decimal have 0.08. So it will be 1.2, and here 0.8. So the value of z will be negative 1.28. So this is the value of z that we can put here. Another way to do that is using a software. For example, Excel. If you use Excel, let's open Excel here. In whatever cell of Excel, you can type equal, don't forget to type equal, normal standard inverse of 0.10 and press enter. If you press enter, the value is negative 1.2815. That is the same value, rounded to 2 decimally is negative 1.28. The table that I have here have the area that are at the left of the number. So when you have a value of z, the table gives you the area at the left of the value z. So usually tables like this have 2 pages. There are other type of tables that have just the area between the number and the center of the distribution. In this type of table, you will look for 40%. If this is 10%, this will be 40% between z and 0. You can find the area corresponding to 0.40 in the area, and it will give you a value z that will be positive, but you know that z will be negative in this case. Okay, anyway, we have the value of z. We can make a substitution in this formula. So let's do this substitution here, and z equal negative 1.28. The value of x, we see that is 0.40, so this will be equal 0.40 mu minus mu divided by sigma. So 0.40 mu minus mu, that will be negative 0.60 mu. So we have negative 1.28 is negative 0.6 mu divided by sigma. So we have a value of mu divided by sigma, a relation between mu and sigma. So the only that we need to do is just divide the equation by 0.6. So apply 0.6 at the bottom of this side of the equation. The minus sign, of course, cancel. So we have that this is 1.28 divided by 0.6. This answer is going to help me also to find the other question, the probability that the random selected worker is paid more than 30%. So leave it there. But the coefficient of variation is the reciprocal of this. It will be sigma divided by mu. So if mu divided by sigma is 1.28 divided by 0.6, then sigma divided by mu will be 0.06 divided by 1.28. And that is 0.4688. So we have a coefficient of variation of 0.4688. This is equivalent to 46.88%. So we have the coefficient of variation, and we can use this value here to answer the second question. So we don't know mu, we don't know sigma, but we know mu divided by sigma, and that will be helpful for the next question. Okay, let's answer this second question. I'm going to leave the answer mu divided by sigma equal 1.28 divided by 0.6 because we are going to need it. We don't have mu, we don't have sigma, but this ratio, mu divided by sigma, will be useful for solving the second question, the question related to the probability. Let's leave this result here and start solving question 2. What is the probability that the random selected worker is paid more than 30% above average pay? So we need to think what is the 30% above average pay. So the average pay is mu, so that will be mu plus 30% of mu. So mu plus 30% of mu, it will be 1.30 mu. So 30% of mu is 0.3 mu, or 0.30 mu. So 1 mu plus 0.30 mu, that will be 1.30 mu. So if we make the graph of the distribution, let's make this graph here. The graph of the distribution, we think we have here in the center mu, and 1.30 mu will be a number that it will be more than mu. So let's see that is this number here. So this will be 1.30 mu. And the question is, what is the probability that the random selected worker, so what is the probability or what is the proportion of workers that earn more than this number, 1.30? So it will be this area here. So this will be the probability, this area, the probability that the random variable x will be greater than 1.30 mu. So this will be this area. We can go again to the standard normal distribution variable and try to get the z that is corresponding to this 1.30. What will be this z? So in the standard normal distribution, what will be the z value corresponding to this 1.30 mu? So we're going to use again this formula, z equal x minus mu divided by sigma, and we know the value of x, that is 1.30 mu. So let's make a substitution of this. Let's type it here. So it will be z equal to 1.30 mu minus mu divided by sigma. And 1.30 mu minus mu will be 0.30 mu. It will be equal 0.30 mu divided by sigma. And now we can use the fact that we know how much is this mu divided by sigma. Mu divided by sigma is 1.28 divided by 0.6. And we have that z equal 0.30 times 1.28 divided by 0.6. This is equal to 0.64. You can use your calculator for doing that. And now we can find the area that is to the right of the z value here. So of course we can use a software or we can use a table. So to get the probability of the random variable x is greater than 1.30 will be the same of finding the probability that the z is greater than 0.64, and this is the value that we can find in the table. So let's take the table and let's find the value z equals 0.64. In a table that we have here, we go here until 0.6, and the second decimal is 4, that is here at the top, 0.64. And then the value that is in the same row and the same column is the 0.7389. This value will be this area here that I show you with the cursor of my mouse. This blue area, because remember, this table is giving you the area to the left of z. There are some tables that give you only the area from z to 0, from z to the mean. But in our case, we have a table that has all the area to the left of z. Okay, let's use this number, z 0.64. The white area will be 1, the whole area, 1 minus the blue area. So the probability that z is greater than 0.64 will be 1 minus this number, 0.7389. So this will be 1 minus 0.7389. So that's the way that you do it using a table. So the answer is 0.2611. If you are using Excel, for example, okay, you don't have a table, so you can, in Excel will be 1 minus the probability distribution of this value 0.64. The value z that we have, that is 0.64. So in Excel, so let's open Excel. In whatever cell of Excel, you can type 1 minus. So anytime that you want to look for an area to the right of the value z, you can do 1 minus the probability distribution, the normal distribution in this case. Yeah? So it will be 1, let's type here, 1 minus normal standard distribution of 0.641. Press enter and Excel is going to give you the answer. Let's do that. Enter. The answer will be 0.261063. That is the same answer that we obtained here, but now with more decimals. So if you use a table, you are going to find the value or the answer rounded to 4 decimals, a table like this. Okay, and that's complete the problem. So you can see that there are some occasions when a problem can be solved despite that you don't have the mean and the standard deviation. So with that, I finish this problem. I hope you have learned something here. Don't forget to like if you find it useful. Okay, thank you for seeing this video, and I hope to see you next time. Thank you.